How Boeing 787 Dreamliners are made inside the final assembly line, full process. Intro. What does it take to build one of the most advanced passenger aircraft ever created? An airplane capable of carrying hundreds of passengers across continents and oceans while using cutting-edge technology to improve fuel efficiency, comfort, and performance. Today, we are going inside the final assembly line of the Boeing 787 Dreamliner to witness one of the most remarkable manufacturing processes in the aviation industry. From giant carbon fiber fuselage sections and sophisticated avionics to powerful engines, advanced composite wings, luxury cabins, and rigorous testing procedures, every Boeing 787 Dreamliner goes through an extraordinary journey before taking to the skies. The Boeing 787 is considered a revolutionary aircraft. Unlike traditional airliners that rely heavily on aluminum construction, the Dreamliner uses advanced composite materials throughout much of its structure. This innovation helps reduce weight, improve fuel efficiency, and enhance passenger comfort. But behind every completed Dreamliner lies a manufacturing operation involving thousands of engineers, technicians, suppliers, and highly specialized machines working together with incredible precision. Inside the assembly facility, enormous aircraft sections arrive from production sites around the world. Massive cranes move components weighing dozens of tons. Technicians connect thousands of systems. And slowly, another Dreamliner begins to take shape. The scale is breathtaking, the technology is extraordinary, and the precision is truly astonishing. So sit back, relax, and let's go inside the Boeing 787 final assembly line to discover the complete process of how these incredible long-haul aircraft are built. Section 1: Designing the Dreamliner. Before manufacturing begins, years of engineering and research take place behind the scenes. Designing a modern airliner is one of the most complex challenges in engineering. The Boeing 787 was created to improve fuel efficiency, reduce operating costs, and provide a better passenger experience. Engineers used advanced computer modeling to design every part of the aircraft. Aerodynamics, structural strength, weight reduction, environmental performance, passenger comfort, and safety, everything had to be optimized. Unlike previous generations of aircraft, the Dreamliner uses extensive composite construction. These lightweight materials offer excellent strength while reducing overall weight. Thousands of simulations were performed before physical production began. Engineers analyzed airflow, structural loads, weather conditions, and system performance. Only after years of testing and refinement was the design approved. Now manufacturing could begin. Section 2: Producing the composite fuselage. One of the most distinctive features of the Boeing 787 is its composite fuselage. Traditional aircraft use large amounts of aluminum. The Dreamliner relies heavily on carbon fiber reinforced plastic. Manufacturing begins with carbon fiber materials that are layered carefully into molds. Automated fiber placement machines position the material with remarkable precision. Each layer contributes to the strength of the final structure. The composite sections are then cured inside enormous autoclaves. These giant pressure ovens apply heat and pressure to create extremely strong structures. The result is a lightweight yet durable fuselage section. Large barrel-shaped sections are produced separately. Unlike traditional aircraft, which require thousands of metal panels and fasteners, these large composite sections simplify assembly and reduce weight. Each section undergoes extensive inspection before shipment to the final assembly line. Section 3: Building the wings. The wings are among the most important components of the Dreamliner. They generate lift, store fuel, and contribute significantly to overall efficiency. Wing production begins with advanced composite materials similar to those used in the fuselage. Massive wing spars form the structural backbone. These components must withstand enormous aerodynamic forces during flight. Engineers carefully assemble ribs, skin panels, and internal structures. Fuel systems are integrated inside the wings. Hydraulic lines, electrical wiring, and flight control mechanisms are installed. One of the most recognizable features of the 787 is its elegant wing design. The wings flex significantly during flight, improving efficiency and reducing structural stress. Every wing undergoes rigorous inspections before moving to final assembly. Section 4: Manufacturing the tail section. At the rear of the aircraft is the empennage, commonly known as the tail section. This includes the vertical stabilizer and horizontal stabilizers. These structures play a vital role in maintaining stability and control. Composite materials are used extensively here as well. Large molds help create precise aerodynamic shapes. The rudder and elevator control surfaces are assembled separately. These movable components allow pilots to control the aircraft's direction and attitude. Sensors, actuators, and electronic systems are integrated during production. After inspection, the completed tail components are transported to the final assembly facility. Section 5: Arrival of major aircraft sections. One of the most fascinating aspects of Dreamliner production is global manufacturing. Different sections of the aircraft are built in specialized facilities around the world. These massive components are transported to the final assembly site. The logistics operation is extraordinary. Fuselage barrels, wing sections, tail assemblies, landing gear components, and countless other parts arrive according to carefully coordinated schedules. Inside the assembly facility, giant cranes unload and position the components. Each section must arrive in perfect condition. Inspection teams verify quality before assembly begins. Now the aircraft can finally start coming together. Section 6: Joining the fuselage. The first major step in final assembly is joining the fuselage sections. Large barrel-shaped structures are positioned using specialized alignment equipment. Precision is critical. Even the smallest deviation could affect aircraft performance. Technicians connect the sections using advanced fastening systems. Structural joints are inspected thoroughly. Thousands of measurements verify alignment. Once connected, the aircraft's full fuselage begins to emerge. For the first time, the Dreamliner starts looking like a real airplane. The size is impressive. The level of accuracy required is extraordinary. This stage forms the foundation for everything that follows. Section 7: Installing the wings. Next comes one of the most dramatic stages of assembly. Wing installation. The wings are carefully positioned beside the fuselage. Massive lifting equipment supports the structures during installation. Engineers and technicians work together to align the attachment points precisely. The connection must be extremely strong. During flight, wings experience enormous loads. Once secured, technicians connect hydraulic systems, fuel lines, electrical wiring, and flight control mechanisms. Extensive inspections verify proper installation. At this point, the aircraft finally resembles a complete airliner. The iconic Dreamliner shape is now clearly visible. Section 8: Landing gear. Installation. The Boeing 787 is a large aircraft that requires robust landing gear systems. These components support the aircraft during taxiing, takeoff, and landing. Manufacturing begins with high-strength steel and titanium components. Shock absorbers, brakes, wheels, and hydraulic systems are assembled carefully. During final assembly, technicians install the nose landing gear first. Main landing gear assemblies follow. Hydraulic lines and electronic controls are connected. The aircraft can now stand on its own wheels. This is a major milestone in production. Section 9: Engine installation. The Dreamliner is powered by some of the most advanced jet engines in aviation. Depending on customer selection, aircraft may use either Rolls-Royce or General Electric power plants. These engines are engineering masterpieces. Each contains thousands of precision-manufactured components. Large fan blades, compressors, combustion chambers, turbines, and sophisticated electronic controls. Specialized lifting equipment positions the engines beneath the wings. Technicians connect fuel systems, hydraulic systems, electrical connections, and monitoring equipment. Once installed, the aircraft begins to look truly complete. Section 10: Electrical and avionics installation. Modern airliners rely heavily on electronics. The Boeing 787 contains hundreds of kilometers of wiring. Technicians install wiring harnesses throughout the aircraft. These systems connect every major component. Flight computers, navigation systems, communication equipment, weather radar, autopilot systems, and countless sensors. The Dreamliner uses advanced avionics technology to improve efficiency and safety. Every connection must be verified. Engineers perform detailed inspections and functional testing throughout the installation process. Section 11: Cockpit assembly. The cockpit serves as the command center of the aircraft. This is where pilots manage every aspect of flight. Large flight displays are installed. Control panels are connected. Navigation systems are configured. Flight management computers are integrated. The Dreamliner cockpit features advanced digital technology designed to improve situational awareness and reduce pilot workload. Communication systems and emergency equipment are also installed. Every control, switch, and display undergoes testing. The cockpit must operate flawlessly under all conditions. Section 12 Cabin Installation. Now attention turns to the passenger cabin. The Dreamliner is known for offering a comfortable travel experience. Large windows are one of its signature features. Technicians begin by installing insulation materials. Floor structures and side panels are added. Cabin wiring and environmental control systems are connected. Passenger seats are installed according to airline specifications. Some airlines prioritize high-capacity layouts. Others focus on premium travel experiences. Overhead bins, galleys, and lavatories are added. Lighting systems are installed. The Dreamliner features advanced LED cabin lighting designed to improve passenger comfort. Entertainment systems and connectivity equipment are integrated. Slowly, the empty fuselage transforms into a modern passenger aircraft. Section 13 Painting the aircraft. Before testing begins, the aircraft receives its final paint scheme. The entire exterior is cleaned and prepared. Specialized aviation coatings are applied. These paints protect the aircraft from weather, corrosion, and ultraviolet exposure. The paint must also remain lightweight. Even small increases in weight can affect fuel efficiency. Airline branding and logos are added carefully. After painting is complete, the aircraft finally takes on its finished appearance. The transformation is remarkable. Section 14 System Testing. Now comes one of the most important stages of production. Testing. Engineers activate the aircraft's systems for the first time. Electrical systems are powered up. Hydraulic systems are pressurized. Flight controls are tested. Navigation equipment is verified. Computers monitor thousands of parameters. Every system must function perfectly. Any issue discovered during testing is corrected immediately. Safety standards in aviation are among the strictest in the world. No detail is overlooked. Only after passing these evaluations can the aircraft move forward. Section 15 Engine Runs and Ground Tests. The moment finally arrives. The engines are started. For the first time, the completed Dreamliner comes alive. Engineers monitor fuel flow, temperatures, pressures, and performance data. Power levels are increased gradually. The sound of the engines is incredible. Taxi tests follow. Pilots move the aircraft across the airfield to evaluate steering and braking systems. Flight control systems undergo additional verification. Every result is analyzed carefully. The aircraft must demonstrate complete readiness before its first flight. Section 16 First Flight and Delivery. The first flight is one of the most exciting milestones in aircraft production. Test pilots take the Dreamliner into the sky. Engineers monitor performance throughout the flight. Handling characteristics, engine operation, fuel efficiency, navigation systems, and flight controls. Everything is evaluated carefully. Multiple test flights may be conducted before final approval. Once certification requirements are met, the aircraft is prepared for delivery. Customer airline representatives perform their own inspections. Documentation is completed. Training programs are finalized. And eventually, the aircraft begins its journey into commercial service. Rows of completed Dreamliners waiting for delivery represent years of engineering, manufacturing, and testing. Each one is a remarkable achievement of modern aviation. Conclusion. From advanced composite materials and giant fuselage sections to sophisticated avionics, powerful engines, luxurious cabins, and rigorous testing procedures, the production of the Boeing 787 Dreamliner represents one of the most impressive manufacturing processes in the world. Every aircraft is the result of thousands of skilled professionals working together with incredible precision. The Dreamliner has transformed long-haul travel through innovation, efficiency, and advanced technology. And now, whenever you see a Boeing 787 soaring high above the clouds, you'll understand the extraordinary journey it completed before taking its very first flight. Thank you for watching this complete inside look at how Boeing 787 Dreamliners are made inside the final assembly line. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more amazing factory tours, engineering documentaries, and manufacturing stories from around the world. Airplane Factory Globe.